Now consider one more example on this Thevenin's theorem for the dependent current source. It is a current source. So this is a dependent and one independent voltage source. It has a 3 resistors here, and this is a current source phi I. This phi I depends on how much current is flowing through this 20. So for this circuit, we have to determine Thevenin's equivalent circuit between terminals AB. We'll go for the step 1. The first step is determine the open circuit voltage between these 2 points. When coming to the VAB or VThevenin or open circuit voltage, the drop across this 8 ohm is the Thevenin's voltage. Yes. Now look at this one. I am creating two meshes here. One is X, another one is Y. Between these two mesh or between these two loops, there is a one current source here, dependent current source, phi I. Whenever this current source between two meshes, then we are going to call it as a super mesh. So we'll use a super mesh technique and solve for these two currents X and Y. This phi Y and X and Y. This is the phi Y is there and X is there Y. So, and also this X is equal to I here. And this Y minus X is, it is a phi Y. And I is equal to X, this is the phi X. This is for this current. Now, for the super mesh, this is the super mesh here. In this 20 ohm, 2 ohm and 8 ohm, and will comes to this 20 volt source. For this, I will apply a KVL here. 20x and 2 plus 8, 10y is equal to 20 volts. And solving these two simultaneous equations, x is equal to this 0.25 and y is equal to this y 1 point. And once we determine the y, the drop across this 8 is the voltage across this. VThevenin is 1.5 into 8, 6 volts. So we determine the open circuit voltage. Next is the Thevenin's impedance. To determine the Thevenin's impedance, whenever this dependent current or voltage source comes, we cannot directly determine. The only way is find out the short circuit current between two terminals. When I shorted here, this resistor becomes 0. This becomes as a 0. So this is the circuit here. Again, and then this is the super mesh here. And again, as usual, y minus x is equal to 5y 5x or 6x minus y is equal to 0. Now come to this 20x, 2 only. Now 8 is 0 because when I shorted here, this will be 0 resistor is equal to 20. And solving these two equations, first equation and second equation. These two equations, x is 0.625 and y, this short circuit current is y. So y is a 3.75. Then Thevenin, the third step is open circuit voltage divided by ISC 1.6. In this way, we can replace the given network.